This video is on graphing radical functions. I'm going to do 6 examples. The first 4 examples are just translating square root functions, either up, down, left, or right. We're going to talk about the domain and range of the function, the transformation of the function, what the key or start point is, and then we're going to have our table. Then we're also going to graph it as well. So the first example is we're going to graph the square root of x plus 2. Now we do want to figure out our key point, which comes from our h and k. That's why we need to know our a, h, and k as always. So the key point here is your h and k. So the h value of our key point is what will make this 0. X, a value of 0 would make this 0, so our key point is 0, comma. Then our k value would be this positive 2. So this is actually our key point, and with square roots, this is our start point. So we would actually write 0, 2 as our start point. That tells us that no matter what, when we graph this, if we use our calculator to graph this, when we look at our table, we want to make sure that our start point is 0, 2. We won't go above that. So let's go figure out the rest of your coordinates by using our calculator. So if we go to y equals, we're going to type in the square root of x, but then we're going to get out of the radical because that plus 2 is not inside of it. Plus 2. And now we can press graph, which I just want to go to a standard window. And as you can see, this graph does not go to the left forever, and it also is not going down forever. It's going to the right and up. So that will affect our domain and our range. Now it does start at 0, 2, and if we go to our table, which is second graph, we have errors here because we can't take the square root of a negative without getting an error. So 0, 2 is actually our start point, which is what we said it should be. The next good coordinate would be 1, 3, so I'm going to put 1, 3 here. Then we do have some decimals, which we want to try and avoid if possible. Next good coordinate would be 4, 4. Because if you think about it, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, plus 2 is 4. That's where that came from. The next one should be 9, because the square root of 9 is what gives us 3. 3 plus 2 is what gives us 5. So it would be 9, 5. And then our graph only goes up to 7 on here, so we can stop right here. So if we were to graph this, 0, 2 is our first coordinate. 0, 2. We have our x and our y, and we have our scale. 0, 2 is not located there. I apologize. I will erase that. That was 2, 0. My apologies. 0, 2 is up here. And then the next coordinate is 1, 3, which 1, 3. Next coordinate would be 4, 4. And then it would go to 9, 5, somewhere over here. So when we graph this, it does start here. That's why we want to know that it's a start point. So it starts here, and it connects these points, and it goes off forever in that direction. There's no arrow on this side because it does not go to the left. So the domain is from your h value, starts with your 0, close bracket, 0, comma, and it goes to the right forever. So that's a positive infinity, open bracket. Our range, this is not going up and down, it's only going up. So we know we're going to have a positive infinity. We also have a positive a value. Our k value is where it starts from, so it's close bracket 2, comma, positive infinity. That would be our range. The transformation from the parent function of y equals just the square root of x comes from your a, h, and k. So if we remember, a equals, it's going to be a positive, a equals a 1, h equals a 0, and k equals a 2. The square root of x is our parent function. So the a value is supposed to be a positive 1. Positive 1, that means that there's no change, no change. X plus, there's nothing inside the parentheses, inside the radical, there's nothing inside the radical. That should be at 0, there's no change. But the k did change. That means that we do have a change in our transformation. This is a positive 2. To get from 0, 0 to 0, 2, we go up 2. That is your transformation, is up 2. So there is no other transformation on there because everything else, there was no change from the parent function of the square root of x. On example 2, we're going to graph y equals the square root of x minus 3. So again, let's find our key point or our start point. Since it is a square root, this will be a start point. Our start point is what makes the square root inside the square root 0. That's our h value. That is 0, comma. And then what is our k value outside of it is that negative 3. So that is our start point. So we'll put 0, negative 3. Now if we go into our y equals and we graph this, so again we have the square root of x, and then outside of that is minus 3. We'll press graph. We'll look at this graph. You see how it does not go to the left and it does not go down. So it does have a start point, which looks like it is at 0, negative 3. We'll go to our second table. 0, negative 3, and after that is error, so that's good. So 0, negative 3 is our start point. Then we have 1, negative 2. 1, negative 2. And then the next good coordinate is 4, negative 1. 4, negative 1. And the next good coordinate would be 9, 0. 9, 0. So if we are to graph this, we would go to 0, negative 3, then 1, negative 2, 4, negative 1, and the next one would be 9, 0, which is over here. So it is a start point, so we're going to start at this location and then have one arrow on here. That will affect our domain and range. So our domain, again, comes from our h value, which is 0. It is going not left, it is going right. So that will give us a positive infinity. So it's going to start from 0 and go to positive infinity with an open bracket. Our range comes from our k value, but this graph is going up, which tells us it's a positive infinity. So we're going to have a closed bracket of negative 3 and then a positive infinity. For our transformation, again, it comes from that y equals the square root of x. So our a from our problem is a positive. A is also equal to a 1. Our h was a 0, and our k was a negative 3. So from the original, it's supposed to be a positive 1, 0, 0. That's from the original. So we have a positive, a 1, a 0, but we do not have a 0 here. So this is the change. This is the transformation that happened. This is from 0, 0 to 0, negative 3. We went down 3. So from this coordinate down is how we got to that location. So we went down 3. That is our transformation. On example 3, we're going to graph this one. This one is also going to be translating it horizontally. That means it's going to go left or right. So we're going to, since we're dealing with a square root, we will have a start point. Our h value, so if we go inside of our radical, what will make the inside of the radical 0? Negative 2 plus 2 is what gives us 0, so x would have to be negative 2. So this would be negative 2, comma. The k value on the outside, there's nothing out there, so there's 0. So our start point is negative 2, 0. So this time, when we go to our graph, go to our y equals, if we retype, it's the square root of x plus 2, so this is inside the radical still. Now I can get out of the radical, but now I can press graph. And we had negative 2, 0, and that is at negative 2, 0. So if we go to our table and get some other coordinates, we want to go to negative 2, 0 should be our start point because everything else is errors, so that works. So negative 2, 0 is our first point, which we already wrote down. And then we want negative 1, 1. Negative 1, positive 1 is the next coordinate. Next good coordinate is positive 2, positive 2. The next good coordinate will be positive 7, positive 3. And our graph only goes up to 7, so that's the many points we can do. So to graph this, we have negative 2, 0, negative 2, 0, negative 1, 1, negative 1, 1, then positive 2, positive 2, and then positive 7, positive 3. So again, since this was our start point, we don't have an arrow over here. We want to connect these, and then we'll put our arrow on the end of that one. But this is our start point, so there's nothing after this. So if we think about our domain and range, our domain again comes from our h value, which will be the negative 2. It starts at negative 2 and it goes right, so it goes to the positive infinity. So we'll start with negative 2 and it goes to positive infinity. Our range is from our k, so that's our 0, and it's going up, so that means it's a positive infinity. So we'll have a 0 and a positive infinity. Our transformation again comes from our h and k from our original. So if it was y equals the square root of x is the parent function because it's a square root, our a is a positive, our a is a 1, our h is a negative 2, and our k is equal to a 0. So from the original, a and a did not change. The h did change, the k did not. So the only change that happened was from the h. So to get from 0, 0 to negative 2, 0, we went left 2. That is our transformation. This example, since we're dealing with the square root, again we're going to have a start point because it's a square root. The h value is what will make this 0 inside of our radical. So it's 3 minus 3 gives us 0. So our h value is 3, comma. Our k value on the outside, there's nothing out here at all, so that's 0. So our start point is 3, 0. So when we go into our y equals and we graph this one, we have the square root of x minus 3, and then we get out of the radical. Make sure if you have parentheses, you close your parentheses after the radical. So then we can graph this, and this time it went to a positive 3, 0, and it looks to be at a positive 3, 0. So we go to our table to get the other coordinates. These up here are errors because if we look back at the graph, there's nothing over here, so that makes sense. So 3, 0 is our start point. The next good coordinate is 4, 1. So 4, 1. The next one would be 7, 2. And we don't have any more on our graph that we can do, but we can still write down 12, 3. So if we graph these, we start off at 3, 0. This is our start point. 4, 1. And then 7, 2. And we can't go any further along that. We can't reach 12, 3. Remember, this is your start point, so there's no arrow over here. But we connect these and we'll have an arrow going to the right. So when we do our domain, it starts with, we have our h value is 3, and it's going to the right, so that's a positive infinity. So we have a closed bracket, 3, positive infinity, open bracket. Then our range comes from our k value, and our range is going up, so it's going to be a positive infinity. So we have a closed bracket, k value is 0, going to positive infinity, open bracket. Our transformation still comes from our a, h, and k, but again, it's based off of our parent function of square root of x. Our a is a positive, our a is a 1, our h is a 3, and our k is a 0. So this has no change from the parent. This has no change from the parent. This one does change from the parent. This one has no change from the parent. So the only change is the h, which again, to get from 0, 0 to 3, 0, you have to move right 3. So our transformation is just right 3.